Hey everybody, and welcome to Friday. Pretty sure. I don't know. You're there. I'm not. I think it's Friday. Today what we're going to be talking about are functions. So again, at the top of a brand new fresh sheet of paper, write functions at the top and underline that. It's going to be very similar to what we have been doing, where we're going to take some value and plug that into something else. Okay? A lot of this substitution that we've been talking about. Okay? The difference is functions are going to have two variables. They're going to be equations with two variables, which is a workable definition for what we are doing right now. An equation with two variables, such as 3x equals y. Now here's the deal. Like yesterday, when we were plugging values in and say, okay, could this be a reasonable solution? Like, if I plug 5 in, do I get a true statement by the end? Does that work out? Because I have a variable on both sides of this equation, almost everything kind of works out. There's some exceptions, but pretty much everything works out. So every time you put something in, you get something else out, though. Let me demonstrate. If I put in, let's make a really quick table, x and y. And let's go just 0, 1, 2. Let's keep it simple for now. For each of these values, when I plug them in, I'm going to get a different number. If I plug 0 in, that becomes 3 times 0 equals y, and then 0 equals y. So y will be 0. For 1, 3 times 1 equals y. 3 times 1 is 3, so 3 is what y is. For 2, 3 times 2 is 6, so 6. And what we're doing here, if you remember before when we've worked with, not in this class, but in other classes, when you've worked with the coordinate plane, what we're doing is we are creating ordered pairs with our inputs and our outputs. So when we put in 0 for x, we get out 0 for y. When we put 1 in for x, we get 3 for y. Put in 2, we get 6, so on and so forth. And some of these you're going to see some patterns, but do not be tempted to fall into those and use those because the patterns are not always going to work. So let's do just a couple of sample problems. And I'm going to format these. I need a better marker than this. There we go, this one. I found a better marker. You aren't here to appreciate the awkwardness. You'll have to appreciate it from a distance. I am going to format these exactly like the homework. So the homework is going to ask you to fill out a table of x and y values for 0, 1, 2, 3, and I believe it goes all the way to 4. Okay? So let's create an equation, 2x, or create a function here, 2x plus 4 equals y. So we've got a variable on our both sides. We have all of our inputs. So what we need to do now is find all of our outputs for these values. So we'll start at the top, at the very beginning. A very good place to start. That's a reference to the sound of music. Start with 0. So we're going to take 0 and we're going to plug it in for x. I mean, we're in the x column, so we're going to plug all of these values in for x. We could use different variables up here, but because this has to do with the coordinate plane, we want the x-axis, we want our y-axis, and x is traditionally the input. So when we plug 0 in, we get 2 times 0 plus 4 equals y. As I reminded you several times yesterday, and I'm going to continue to remind you, do your multiplication first. 2 times 0 is 0, plus 4 equals y, 4 equals y. So our first pair is 0, 4. Then we have to do, our next input will be 1. 2 times 1 plus 4 equals y. 2 times 1 is 2, plus 4. 2 plus 4 is 6. My output will be 6. So when we plugged 1 in, we did the math, we simplified, and got 6. 2. 2 times 2, because we plugged in the 2 for x. Remember, this is multiplication. When a number is next to a variable, that's multiplication. plus 4 equals y. 2 times 2 is 4, plus 4, 4 and 4 make 8, equals y. So my output here is 8. And 3, 2 times 3 is 6. Always do your multiplication first. 6 plus 4 is 10. And some of you are probably noticing the pattern at this point. From 4 to 6 is an increase of 2. 6 to 8 is an increase of 2. 8 to 10 is an increase of 2. 10 to 12 then is our guess. Okay? So we're going to take 4 and plug that in. 2 times 4 plus 4 equals y. 2 times 4 is 8. 12 equals y. So we got it. Now, this is that point where you might say, oh, there's a pattern. You just keep increasing by actually the x value. 2 times x. We're going to increase by that much every single time. But that is not always true, so be careful around that. Let me show you a counterexample to that. For the sake of brevity here, I'm only going to go to 3, just because then you have to listen to me on the whiteboard for a shorter amount of time. Let's go with x squared plus 4 equals y. Again, we've got my variables on both sides, but this time I've got this x squared, and that's where things get a little bit funny. So 0 squared plus 4 equals y. 0 squared is 0. 4 will be my output. So here, 1 squared plus 4 equals y. 1 squared is 1, plus 4 equals y. 5 equals y. Okay? So we may say at this point, well, I see the pattern already. We're increasing by 1. But wait, there's more. Let's plug in the 2. 2 squared plus 4 equals y. 2 squared is 4, plus 4 equals y. 4 and 4 are 8. Now we've increased by a different amount, and that pattern is gone. Now, I will say there is technically a pattern, but it is buried and a little bit harder to find, to the point of not being useful, so we're not going to bother talking about it, other than to say the pattern that you think you see early on is not always going to be a pattern. So just be cautious with that and watch yourselves. Let's do 3. 3 squared is 9, plus 4. 9 plus 4 is 13. 13 equals y, so my output here is 13. So an increase of 1, an increase of 3, an increase of 5. And again, there is a pattern there, but I don't want you to rely on that because it can be a little bit messy, and it's really easy for me to mess with this to make it even harder to find. So do the math. All right, let me write one more here for you to try on your own. So we're going to pause the video in just a second here. And again, for the sake of brevity, 0, 1, 2, 3. And let's do a 3x plus 5 equals y. Go ahead, pause the video, and take a moment and create your inputs and your outputs for this function. All right, cool. Let's go through the answers here. So first, we're going to plug in the 0. 3 times 0 plus 5. 3 times 0 is 0 plus 5 equals y, which will be 5 equals y. So 0 is 5 is my output there. For 1, that'll be 3 times 1 plus 5 equals y. 3 times 1 is 3, plus 5 is 8. And then 3 times 2 plus 5. 3 times 2 is 6, Whoops. Jumping the gun there. 6 plus 5 is 11 equals y. Sorry about that. 3 times 3 plus 5, 9 plus 5, and 14 equals y. Okay, so that's the idea behind functions, trying to get a whole bunch of ordered pairs between our inputs and our outputs so that we can eventually graph these on a coordinate plane. Okay, thanks for watching. Hope things are going well for y'all. Hello from Florida, and I'll see you tomorrow.